Awesome. So welcome to DS10. Today we're going to talk about making features on a data set. Now, what do I mean when I say the features of a data set? What do you think? What is a feature on a data set? Okay, we got a couple. We got a couple ideas. Columns, rows, columns not included in the data set. Row items, the shape of the data set, the data types, the attributes we looked at to gain insight. Those are all good ideas. And so I'm glad I answered this question. In OpenCV, it's something to track, give, or take. All right. We will probably work with OpenCV, but not for a couple of months. Yeah. So when I say features of a data set, there's a few different synonyms that could all be used similarly. So feature is the same as attribute. So we had attributes. That's what UCI called them yesterday. We could also call them dimensions, but the most common name is columns. A feature of a data set is just a column on a data set. So today is all about how do we work with columns of data sets with pandas, right? And how do we do operations to specific columns? Because a lot of times there's going to be things we want to do that we don't want to do to the whole data set, or that we only have this problem or this data cleanliness issue in a specific column. So we want to be able to operate on just that column, right? But what is really important is that the way that we work with each specific column depends on the kind of data that is held in that column, right? So if our column holds string values, then we'll need to modify that column according to the properties of how we work with string values. And it's holding something that's numeric, then we can do numeric things to it. But we have to be a little bit careful before we go to work with a column that we're conscious of the type of data that is held in that column so as to work with it. Another thing we have to be conscious of is we have to be conscious of if there's missing values in that column, particularly NaN values in that column, because that will change a little bit how we work with things. So this is what we're going to focus on today. We're going to try and get better at working with columns of a data set. So the lesson is titled Make Features, because not only are we going to modify existing columns on the data set, we're going to take our first foray into something called feature engineering, which is where we'll take columns of our data set and use them to make new columns. And the hope is that the new columns that we make, they will help expose some signal in our data, some patterns in our data in a way that was previously not as visible. All right, so imagine for a minute here, and I'll share my screen in a minute when I'm kind of done with some of this intro. Imagine that we had a data set that had home values, right? And in the data set, it's got a whole bunch of things about homes. It's got their square footage, their lot size, number of bedrooms, number of bathrooms, and it's got one column that is the price of the home. All right, so those are the columns that I have in my data set, those 4 or 5. What if I wanted to make a new column that was price per square foot? What should I do in order to generate that new value? Remember, I have price and I've got square footage. I want a new column that is price per square foot. How might I generate that new column or that new feature? Got a few people typing. I'll give you a sec. Okay, good. And then this might be a little bit hard to think about without anything to look at or anything to demonstrate. But yeah, whenever you hear the word per, think division, right? So price per square foot, or the price divided by the square footage, right? So I'm going to take one column and I'm going to divide it by another column. I'm going to make this completely new column. And yes, I do need to take that new column and append it onto my data frame so it gets added as a new column, right? So, but here's what I'm really getting at. With feature engineering, this new column has been created by columns that were already in our data set, but it says something different about our observations, right? So for example, what would a high price per square foot imply about a home? What would a high price per square foot imply about a home? Good, good. Lots of ideas. Location, it's in a good zip code. It's expensive. It's in a desirable area. It's nice. It's good market value. It's in San Francisco. Very true. It's made of good material, right? It's some kind of indication of the quality of the home or the neighborhood, right? If people are willing to pay more per square foot, then they must be getting more per that square foot, or it's in a competitive market or someplace like that. Likewise, a low price per square foot would indicate kind of something that's low quality. Maybe it's something that's going to need a lot of renovation or need to be flipped or something like that, right? So I want you to think about how making that new column tells us something about our observations that the previous columns didn't tell us. It tells us something new. So even though all the pieces were there, right, we didn't have that indicator until we did some feature engineering, until we made a new column on our data set, right? So today, we're just going to work on some of the basic skills we need for working with columns, and then we'll do feature engineering a ton. We won't do a ton more of it in Unit 1, but you'll do it a lot in Unit 2. It's one way you can really bring your creativity and domain knowledge to a problem to improve the results of some predictive model, right? It's very, very important and core skill in data science, but generally working with columns in general with pandas is going to be an essential skill. We'll see a little bit of the feature engineering side of it today, but you'll get a lot more of that in the future. That's what I'm trying to say. All right. And yes, if it's in San Francisco, I definitely can't afford it. I don't know about you guys. So let's dive in. Before we get going, I want to show you guys how we can open a notebook from GitHub one more time. So right, I'm here on Lambda School. By the way, if you've already forked something and you click the fork button, it will say, hey, you've already forked this, right? So this is one way I can easily get to my forked version of the repository, right? And I believe I'm 2 commits ahead of Lambda School Master. What does it mean when it says I'm 2 commits ahead? Two commits ahead. Yeah, good. So remember, a commit is just a synonym for having saved your changes, right? So it means that changes have been saved to these files 2 different times on 2 different occasions that, and those changes are not contained in the Lambda School Master version, right? So I've saved my work back to this repository twice, which is what we did demonstrating yesterday, which is why this now says I'm 2 commits ahead. If you guys saved your work 4 times as you were working yesterday, you would see you're 4 commits ahead. If you saved it 10 times, it's your 10 commits ahead, right? Just the number of times that you've saved your work, and that number of ways your work is unique compared to the master version. Awesome. If it says you're behind, it means the opposite. It means the master version has some changes that you don't have, right? So if we don't want to be behind at Lambda School. You want to have the most up-to-date resources, but seeing that you're ahead is totally okay. That just means you've been doing some work. All right, so I want to open this make features notebook. Again, it's probably not going to render for me here. Oh, it did. Wow. So this is kind of a shorter notebook. We're going to type a lot of code in this today. So there's a couple of ways I can do it. If I'm here on this notebook, I can click the extension button and have it go open automatically. That's probably the easiest way. But again, I can go to collab.research.google.com/GitHub. And if I'm authorized, I can select the repository that I need and then the notebook. So 2 different ways. This is most likely what you'll do today. You'll open a notebook here, you'll make some changes to it, and you'll save it back to GitHub, and that's all you need to do. Because you've already forked the repository, you've already submitted your pull request, you only need to do those things once a week on Mondays. The rest of the week, it's just open the new notebook, make the changes you need, and then save it back to GitHub, right? So, but like I advised yesterday, I think it is a good copy to save a version to Drive and to not work from this GitHub-based version. If it has the GitHub icon, make a copy of it to Drive, right? So it has the Google Drive icon, then you can come back and you can change your title. If I saved it like this, when I saved it back to GitHub, as long as I changed the file extension, so it got saved to the right place in my repository, it would just get saved over the old version of the file, right? So if I say file, save a copy in GitHub, if I update this file path here, and I add this kind of inner folder name to it. So if I just save it like this, it's going to go in the root of my repository. if I save it here, it's going to go inside the module to make features folder, right? And I can give us some kind of a specific commit message. But I'm actually not going to save this back to GitHub today. What I'm really going to do is I'm just going to share with you guys the link to this collab. And again, this link should work for the lecture notes for forever and never, because at the end of the day, this is just a Google Doc, right? So this should be the only link that you need. Please, if you want to reference this later, grab that link and save it someplace safe. Maybe organize some folder within your own Google Drive of lecture notes or something like that. And again, I'm going to rename this DS10 to make this explicit that we are, that this is the version of the lecture notes that was given to your cohort. And besides that, I think we're ready to go. All right. Any other questions about kind of GitHub and working with GitHub before we really dive into the lecture content here? By the way, I hope that today is a more straightforward day in terms of the schedule, right? You had your warm-up activity in the morning. We're going to have 2 hours of lecture. We're trying to keep it to 2 hours, right? Then you have your hour of lunch and your your regular hours in the afternoon for working on projects. It won't be, you kind of lost an hour yesterday because we went a bit long with lecture. So today, hopefully, will be the typical daily schedule of what you'll experience here at Lambda School. Where do I find the collab from yesterday's lecture? You'll need to scroll up in the chat. I think it was shared a little bit yesterday. Also, if somebody has the link and could just add it in a thread to Robin's question, that would be cool as well. I'm thinking in the future we might take. I haven't talked with TLs about this. We might take the DS10 videos channel and also post lecture note links there as well, even though they're technically not a video. But we'll talk about that. I think it would be good to kind of have those in a easy to access place as well. So you're not always scrolling around trying to find where it was. But I'll let you know more on that in the future. Quinn says, I should have done that. No, that's okay. I mean, it's just a suggestion too. I mean, so Travis makes a good point. He says, even ignoring work loss here in the Google Drive version, if you get in the habit of committing changes, it can be much easier to roll back changes. It may not be useful right now, but I've had times where something was working, now it isn't, and I'm so confused why. That's very true. So let me demonstrate something about that really quickly. So let's see. So here I am in my Ryan Lee Allred fork, and you can see that there's been 13 commits here. If I click on those commits, I can see all the different versions of my files when I made the changes. So one thing that's really important to know about GitHub is it does not only save the changes you made. Every time you make a commit, it saves a completely new copy of the entire repository, right? So this is the repository in the state it was 23 hours ago. This is the repository in the state it was 7 days ago. This is the repository in the state it was 27 days ago, so on and so forth. So if I needed to roll back my changes and go back to using this version of the repository, I could do it using this little ID right here. All right. So that's one of the nice things about GitHub is that it's not only saving kind of the diff or the changes you've made, it's saving the whole version of the repository. And like Travis says, is easy for rolling back changes if needed. So that's something we might not run into a ton until maybe a little bit later on in the course. But particularly if you're working on a big project and you've messed something up and you don't know how you messed it up, sometimes it's easier to just go back to an earlier version. Can we save the lecture notebook now and keep the changes you make, or do we wait until lecture is over? I think you'll need to wait until lecture is over. If you want to save the changes by going File, Save a Copy in Drive, you need to wait until all the information is there. But you could save maybe the link in some kind of a file, or you could DM it to yourself on Slack. You could bookmark it. You could put it in a Google Sheet where you keep track of all of the different lecture notes and lecture videos for a day. Yeah, or just type along. And that's what I suggest. Honestly, the more you guys can type along, the more you'll be able to focus on lecture and absorb more from it. A big part about learning this syntax of pandas and other things like that is just giving your fingers the muscle memory and making them have to find that square bracket key, and learning when to hit shift and when not to hit shift and all those silly things can really be very important. And so I'll say this right now. Part of your assignment today is to what we call replicate the lesson code. All right, so let me share this link with you. This is a small document that was put together by our Unit 2 instructor, Ryan Herr, right? And he's got, some examples about I do, we do, you do. But when we say replicate the lesson code on your assignment, we mean do not just copy and paste stuff from the lecture notes into your assignment, right? Get to where we got to by the end of lecture and then keep on going, but get to that point by literally typing out what you see. Copy and paste. If you copy and paste, you rob your brain of this training of your hands, which will be really important, right? I want you guys to be able to say by the end of the day, an internet thing there. I want you guys to be able to say by the end of the day that you understand every line of code from the lecture notebook. All right, which that might be a little bit of a tall order, but I hope that's something you can aspire to. Okay, that's enough rambling. I need to actually get to lecture typing here, or else we won't get finished. So I have some code here, but it has these bang symbols in the front. Does anybody remember what it means when we see bang symbols in the cell of a Colab notebook? Good. This is a shell command, a bash command, a terminal command, command line command, whatever you want to call it. Yeah, this is not Python, right? So this is something that is as if I was accessing the underlying computer that is running my Google Colab and running commands on that computer itself, right? I could do it on my regular machine if I came here to the terminal. Here's even the output from yesterday, the flags data set. So that's funny that that's still there, right? So again, this wget command is a shell command. And if you want to run it in your actual terminal, I think you need to actually install wget, but it should work fine in our Google Colab. Now, a get request, what that really means is whenever we go and we request a page on the internet, when I go to google.com, I have just made a get request for a file at this location, right? So all that this URL is it's a file path, really. It's a little bit more complicated than that, but yeah, I mean, URL stands for Uniform Resource Locator. It's a location, it's an address. It's a file path, right? So if I go to google.com, well, let's find a better example. If I go to github.com, then I'm on GitHub's root directory. If I go to github.com/Ryan Lee Allred, well, now I'm in the Ryan Lee Allred folder. It's not exactly that simple because this is probably a single page application and not some of our typical more classic websites, but you can think about it that way, and that the file path is just, that the URL here is just a file path to a specific document, all right? Now, in our cases, today, it's a link to this zipped file, all right? Yeah, I saw Elmira was working with this a little bit yesterday, and she was seeing different HTTP requests, GET requests, and seeing the statuses as they came back, right? Notice if I go straight to this URL, it starts an automatic download of the zip file I want to work with. And that was the key indicator from yesterday when we were working with UCI datasets. If we went to the URL and it started an automatic download, then that was the good URL that we could use for accessing that file, right? So just to check that, showing you that that does indeed work. So we should be able to use this URL to get this dataset. Now this dataset comes from the website Lending Club. Lending Club does peer-to-peer loans. So any of you could loan money to somebody else over the internet. And so in order to help people make smarter loans, Lending Club provides a data set about kind of the statuses and properties of all their loans so that you can kind of do some of your own analysis and decide who you want to loan to and who you don't. But I wanted to just briefly show before I finish this. So I go to google.com. Don't worry about what I'm doing here because this is more of a web development thing. If I come here to the network tab, see these statuses. So these are different files that are associated with building this page right here. And when I go to google.com, see all the different files that are being requested, because really this page is made up of a whole bunch of different smaller entities there's maybe it's pulling in a file for the CSS, it's pulling in a file for the JavaScript, it's pulling in a file for the HTML, kind of combining it all together. But see, Google.com had a status of 200. 200 means everything worked the way expected. If you get a status that's in the 400 range, well, then that's missing, like a 404 error, right? If I go to github.com/blah, blah, blah, then GitHub says 404. I don't know what this page is, right? So you get a 404 status error. If you get a status error that's in the 500s, that's a server error. It means the server you're trying to get to has gone down. 300 statuses, I think they mean it's been something that's been moved, right? Et cetera, et cetera. So that's just a very, very quick intro to these statuses. You don't need to know or remember anything that I just told you. Probably the most important thing to remember is just a status of 200 in web request terminology means everything worked the way we expected. All right, so we are going to do a GET request, which is exactly the same thing as if I went and typed in this URL in my bar, but I'm going to do that GET request using the wget command, a GET request, right? So as I run this cell, what it's going to do is it's going to go and grab the file that's at this location and bring it into my Colab notebook. All right, so this is a third way of getting data sets into your notebook, is that we talked about loading something from its URL directly with read CSV. We talked about uploading something from our local machine. This is us going out and grabbing that file over the internet. It's yet a third way of pulling in files to our notebook. And this might take a minute for this to load. You're going to see that this file is fairly large size. And here, take a look at this. HTTP request sent, awaiting response, 200 OK. That told us it got the file successfully. Now it's just kind of doing the downloading bit. All right. And it looks like it's still saving it as a zipped version. It's taking longer than I expected. Maybe I've got slow internet today. There we go. And now it's been saved, right? If we come to our files here, we can see that now we've got the zipped folder inside of our notebook. So I'm going to unzip it using the unzip command. You get another bash command. All right. And it says, oh, it's inflated, and it just has the single CSV in it. So I can now just work with the CSV. So this is a bash command. The head command is very, very similar to pandas dot head that we call in a data frame, right? It's showing us the first, I think, 10 rows of a file. Likewise, I can use the tail command, just like I could with pandas, and see the last 10 rows of the data set. So this is what we're going to do today for looking at the raw file, right? Because that's what I'm seeing here. And then as we look at the raw file, both the head and the tail, is there anything you guys see that might be a problem when we start working with this data set? Any oddities? Okay, so see a few things. We've got a lot of quotation marks around everything, right? Everything is in quotation marks. Quotation mark typically indicates we're using strings, but we do have headers. That's good. But like Caleb mentioned, the headers are not on the first line. The first line of the file is this link here. Yeah, we've got percent signs with numbers, but it's all as a string. That's messy. We've got leading spaces here. What else? Yeah, we got funny characters. We have funny categorical indicators for our strings here. Somebody else said they saw n/a. Where was that at? It's kind of hard to spot sometimes. Anyway, so, oh, and the tail. Gotcha. Yeah, right here. So this is a missing value indicator, but maybe a little bit hard to say if that is an appropriate missing value indicator. December 2018 sounds unpleasant. Where was that at? Oh, like right here. So some of these dates our month slash year, excuse me, dash year. Yeah, lots of empty strings here. It's telling us that maybe this ID column is pretty much blank. All right. So there's a lot of cleaning to be done with this data set. All right. We need to clean up a lot of stuff in order to work with some of these columns. And so as we try and work with those columns, we are going to do the cleaning, but we're going to do it column by column, right? So what we're going to do today, now there's a lot of things we can do with this data set. We're going to work with this interest rate column, which actually this column header corresponds to this column here. And we're going to try and clean this up. We're going to try and make this numeric so that we can work with it. You'll notice it's going to start out as a string, and it's going to have this percent sign on it. And then after that, we are going to work with the employment title column, which corresponds to these employment titles here. Now, this lending club data, it has come from people typing out a web form, right? And so they're supposed to type in their employment title. And what that has done is it's allowed people to put things as arbitrary as they want into that employment title, right? So senior vice president dash risk manager, right? And we have teacher, help tech supervisor, bus driver. So this one's lowercase, this one's uppercase, this one's got an extra title inside of it, et cetera, et cetera. So we're going to need to do a few things to try and clean this up a little bit. We're not going to make it perfect, but we're hopefully going to make this employment title a little bit more standardized as we work with the string values there. And then we're also going to work with some of these dates. Let's see, probably the issue date, which I think actually corresponds to these dates: December, 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 right? We're going to try and clean those up as well and learn how to work with date times a little bit. So some of these times we're just going to modify a column to clean it up. Other times we're going to use these current columns to create completely new columns that yet again say something completely new about the data set. It was made in Excel, maybe. We'll take a further look here. What I'm going to do is right here at the beginning, I'm just going to try and load this data, and I want you to show you what happens if I just blindly try and load it. All right. So first, I need pandas, and then I'm going to say I'm just going to call this data frame equals pd.read CSV, excuse me, and then give it the URL. Well, remember, I pulled in the zipped file and then I unzipped it. So I think here are my files. Yeah, I have loan stats 2018 Q4. I should just be able to use that the file name here because it's already in my notebook memory. And then we'll do we'll print df.shape and df.head. Why am I printing the shape here again? A little reminder, we talked about it yesterday. Yes, because notebooks are weird. That is the most correct answer. Remember, we're printing the shape here because only the last statement in a cell gets displayed. And I want both of them to be displayed. Now, I could put these in separate cells, but I typically, when I'm first starting off with the data set, I do both of these one right after another. So I typically end up printing the shape so I can see them both in the same cell. All right, but we see that everything here is bold. Everything in the data set is bold, right? And bold in these data frame outputs indicates that this is an index, either a row index or column index. We also call the column index the headers, right? So the reason why all of this is bold is because the first line of my data set is this notes on prospectus, and that's being read in as a single cell. And that's being treated as my column header. Remember, read CSV tries to infer the column headers from the first row of the data set, right? So we've got a big issue here dealing with this right here. So what I want you to do, I want you to take a look at the read CSV documentation. I want you to tell me what parameter you think I could use to deal with this problem of the first row. Now, to be clear, there's more than one way to do it. There are multiple ways to make this work. with read CSV. Okay, so the separator parameter, that's how I indicate what the cell separator here. So here it's commas, and I think you'll see that that's the default, right? So the default here is it's a comma separated value, CSV, comma separated value, and we do have commas here. So I think we can leave the separator good to go. All right, so we got a few different ways to do it. We could say that the header is 1. Let's try that, because we've got row 0, row 1. Let me close this. Specifically indicating that my header is row 1. I could also say, let's see. I think skip rows. Line numbers to skip, 0 indexed. So I think if I say, oh, I don't need this 404 page anymore, or Google. If I say skip rows equals 0, maybe. Oh, that said equals 1. Oh, that seemed to do it as well. Maybe 0 would not do what I wanted. Yeah, so skip rows 1, we'll do the same thing. So header equals 1, skip rows equals 1, et cetera, et cetera. All right, so there's multiple ways to do it. For today, I think the thing that, what I like with my code is I like my code to read as close to English as possible, right? Maybe that's just a personal preference, I don't know. But if I say header equals 1, I think that's a little bit more explicit, that my header is row 1. You might disagree, you might want to do it a different way, but I think this has addressed the problem of the column header. We skipped that first row. You notice it's giving us a data type warning. That's just saying, hey, this this data set's pretty dirty. We've got mixed data types in a specific column. So let's take a look at maybe some of our column data types next. I'll say df.dtypes, right? Because remember, as we're working with columns, we need to know what kind of information is in those columns so we know how to work with them. But we're seeing some truncation here. Does anybody remember what we could do to deal with this truncation with pandas if we want to see more rows? Remember what that was called from yesterday? Remember, this is something you'll run into fairly frequently because we have so many columns here, not a lot of columns. Yeah, it's the pandas settings. Its technical name is the display options. All right, so what I'm going to do, and you might get to the point where every time after you import pandas, you just put these 2 rows in. All right, pd.options.display.max rows, and I'm going to set the max rows to 999 and the max columns to 100. And there is more ways to do it. You can use set options, or you can just do set this attribute here. So you're not totally off, Keanu. This might actually be slightly different than how I did it yesterday. I don't remember exactly my syntax from yesterday, but sometimes I will add these rows just right after I import pandas, just to make sure that I can see everything that I want to see. All right, now I can see all my columns. Notice my output gets a little bit long, but we're working with a data set that has lots of columns. So we see data types of object. Remember, object refers to there probably being string values in a column. Float is any numeric value that has a decimal portion. So dot something something, 0.00, 0.05, 0.1, etc. Now you can see some of these columns that we would expect to be floats. 64 just means that it refers to the size of the memory spot that's available. So it will hold a float that fits in 64 bits of space. Yeah, so there's actually different sizes of floats and different sizes of ints. Pandas defaults to float 64, which is pretty big. You should be able to save basically any number you need to in a size 64 memory space. I don't remember if it's the 1s and 0s or the number of characters in the number that's allowed. Might be the 1s and 0s. I should know this. I had to know this back in the day. Is it the binary refers to the binary? That makes sense. So I don't know how big a 64-digit binary number can get, but it's pretty darn big. Somebody can Google it for us or find a binary calculator and type 64 ones into it. 2 to the 63rd, 2 to the 64th. Moral of the story is it's really big. My simple calculator doesn't not even be able to do it. So somebody try it out. Yes, this is a tangent. What I want to point out here is that we have some columns that we would expect to be floats or ints, like interest rate. I probably expect that to be a float, but it's reading right now as object, right? It means that this is being seen as a string when I want it to be numeric. I want to work with it in a numeric fashion, right? So one of the things I'm going to do is I clean this up is I'm going to take this interest rate column and I'm going to make it numeric. I'm going to turn it into a float. All right. Another thing, looks like we don't really have any integer data types in here, which is interesting to me. Kind of different than what we had yesterday. Yesterday we only had integers and objects, and today we've only got floats and objects. Yeah, I'll actually drop these pd.option lines. For your reference. Yeah, sorry, when I copy paste things, I forget you guys are still typing. You don't get the benefit of copying and pasting from my notes like I do. All right, so moral of the story is when we're working with columns, you got to be conscious of the data type. And I've said that 3 times, so I'll just move on. So the next thing I want to do is I want to take a look at null values. All right, so I'm looking for the number of null values in each column, and I'm summing them all up. So here's the different column headers, and here's the number of null values. And you'll see this is still in the order that the columns are on my data set. So maybe I'll even want to sort this. All right. So one thing that's interesting here is I have at least 2 missing values in every single column. This tells me there aren't any single columns that are completely the way that they should be. All right. Which is a little bit interesting. Does anybody have any ideas why I might be seeing twos here everywhere? If I opened a data set and I saw 2s here everywhere here, this would be suspiciously consistent to me. And there might be something else going on. Okay, the first 2 columns are empty, 2 empty columns. Well, so this is referring to the number of rows or the number of cells within a column that are empty, right? So the first 2 columns being empty is what I'm seeing here, with basically the entirety of these 3 columns being empty. But this ID column, it has everything except for 2 values that are empty. So if I look at the shape of the data set, it'll tell me that I have 128,414 rows. Good, good. Caleb's got an idea. Maybe the stuff from the footer of the CSV, right? So remember when we were looking at the tail here, we had these 2 lines at the bottom. All right. These 2 lines are being read in as cells, and because there's no commas here, these are being read in as if they were in the ID column, in this far left ID column, which is why everything except for 2 values in the ID column is missing, right? So this is not 128,414, this is 128,412, right? So we've got some issues at the end of our data set that is kind of messing with these values as well. So for the sake of time, I'm also going to just peek in here at the read CSV, skip footer, all right? Number of lines at the bottom of file to skip, and you notice it's unsupported with engine equals C. I'll talk about that in a minute. So let's see if we can skip 2 lines at the bottom of what we're doing as well. And you'll notice this is going to run a little bit slower, and it's going to give me a warning here because one of the cool things about, well, let me back up. While this is loading, one of the biggest criticisms of Python is that it's not the fastest language in the world. Other C-based languages run a bit faster. So Pandas has tried to create a C-based engine for doing its operations, so it can kind of overcome some of those limitations of slow Python. But not all Pandas functionality has been written to work with the C engine, right? So it says falling back to the Python engine because the C engine does not support skip footer. You can avoid this warning by specifying engine equals Python. So I'll do that as well just to get the warning to go away. All right. Why is it 2 instead of 1? Don't we count from 0 now? That really depends on how the parameter's been specified. Number of lines at the bottom of a file to skip. So this just means the raw kind of counting number. If this said 0 indexed here, then I might, say it was just 1 or something like that. This was some similar thing happened with skip rows, right? Line numbers to skip 0 indexed, but it doesn't say that here in skip footer. It just says number of lines. All right. All right, so that's loaded finally. And you'll notice I have 2 rows less, 128,412. My data types should all be the same. But now as I look at the missing values here, I've got a bunch of zeros, which, phew, I've got at least some columns that don't have missing values in them yet. That should be able to be worked with. Now, I think that, well, let me ask an important question. And let me do that by, let's look at specifically certain columns. Let's look at, first let's look at these 4 columns. The URL, member ID, description, and ID are all completely blank. Why might these 4 columns be completely blank? Has somebody messed up somewhere? Is that intentional? Yeah, so all of this stuff is information that comes from a specific loan. Could be information about a specific loan, but yeah, this is a privacy issue, right? Lending Club wants to provide information about their loans, but they don't want that information to enable us tying any specific row of the data set back to a specific person, right? Because they don't want to dox or reveal personal information of their users. And so what Lending Club is doing here is they're saying, hey, we do collect these 4 pieces of information. We have their member ID, we have their ID, we have their kind of description and their URL, but we're not giving it to you. We're specifically removing this information. We're going to leave the column headers to let you know that we still collect that information, but we're not supplying that to the public, right? So yeah, this is out of respect for user privacy, which is a nice thing that they should do. This is standard operating procedure. The rule of thumb is that you should never make a data set public where you could tie any specific row or any specific observation to a particular individual based on the information in those rows. And so this is Lending Club trying to follow that guideline. Another thing I want to point out here is we have a lot of columns here that have a specific number of missing values, right? So I have 128,412 total rows in my data set. So these hardship rows, there are, well, how many do you think? What's 412 minus 343? 69 different loans that have been issued with a hardship status, right? So here's the question. Almost, let me scroll up so you can see the is no line. Almost none relative to the total number of rows in this data set. Almost none of the loans have been flagged with a hardship status, right? So here's my question for you. Do you think the amount of missing data in the hardship status column is due to us just not knowing if the other loans have a hardship status, or is it more so due to that was something was not applicable to the other observations? And this is something we need to think about whenever we look at missing values. Okay, is this something that was missing, has been omitted from the data set, or is it kind of an NA, not applicable? And that's the reason why it was left blank. It's particularly on surveys or other types of data collection. The missing data does not just mean omitted or forgotten or left out. Yeah, probably NA given the consistency in number, but also difficult to know for sure without context. And that's very true and very, very wise what Lori said. So we could probably make a good guess, right? And my guess is that a hardship status is something that's very rare on a loan. Maybe this is a person who's in a coma. I don't know. That's a terrible thing to say. But for whatever reason, you know, they haven't passed away, but there's no way they can repay this loan, right? And so they've been flagged with this hardship status. This loan is probably less likely to get paid back, right? So one thing that's important is when we work with machine learning algorithms, which is what we're kind of building up to here in Unit 1, machine learning algorithms typically can't work if they have missing values in a data set. All right, so we will need to deal with these missing values in some way if we want to, you know, predict the likelihood of loan repayment or something like that. But we might not want to just straight up drop these columns from our data set, because although these columns are sparse and they're rare, they still hold really important information about loans and about the possibility of loan repayment, right? So as you're looking at null values, please just don't think about everything as missing data. Please try and think more about, well, why might that data be missing, right? And see if you can use some of that detective work to conjecture better ways to deal with that missing data so as to maintain any possible signal that could be there in what data we do have. We're not just going to go and drop columns because they have a high proportion of missing data. We're going to try and be a little bit smarter about it. But the columns that we will drop are these four guys, because they're pretty useless to us. So we're going to go ahead and drop those as we get started. All right, so I'm going to say df.drop URL, member ID, description, ID. So this is not going to work for a few different reasons. All right. Let me run this. And first error, URL, member ID, description ID, not found in Access. What does this mean? What's going on here? Good, good, good. So one thing I really want you to remember about pandas, all right, is that certain functions have been written to work on both either rows or columns, right? So I could drop rows from my data set and I can drop columns from my data set. But it's important to know the defaults of what you're working with. So we come to df.drop. Drop specified labels from rows or column. Remove rows or columns by specifying label names and corresponding axis, or by specifying directly index or column names, right? So axis here, the default is 0. So by default, df.drop is trying to drop rows from my data set, right? So with pandas, remember, always, 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 axis equals 1 means columns. We're going to do this on a column basis. Axis equals 0 is for rows. All right, that's something you'll just need to memorize or look up when you run into this error in the future. So if I say axis equals 1, then I do indeed have these dropped columns. All right, so they're not there anymore. However, if I come here to df.head, they're still there. All right, so what is still wrong about this syntax? Yeah, so this is another thing you need to think about as you're working these functions. You need to be conscious of what they are returning to you. Returns, data frame without the removed index or column. All right, so this means that this is showing the data frame that's getting returned, but I'm not saving that anywhere, right? So if I save this over the original variable, then it will be retained. I could also say in place equals true. Either of those would do the same thing. Like I usually do, I'm not going to use in place equals true. I'm just going to save over it. And sometimes it's good to, like, I don't know. We'll just leave it like this. Yeah. And then if I do df.head, we see that now the changes have been maintained because it's been saved back over this variable, and we're good to go. So now we truly have lost those rows forever. The only way to get them back would be come back up and re-import the data set, right? So this is a dangerous thing to do. Yeah, if we mess this up, then we would have to go all the way back up to the top of our data set and rerun cells to get those columns back in. Maybe I accidentally dropped a column that I didn't want to, or something like that. So what some people will do is they'll say this is df1, right? And so instead of saving back over the original data frame, they'll just change this variable name slightly to make it so that they don't overwrite the original data frame. Now, why is this giving me an error? Similar to what Robert said. Careful to not drop them twice. Yeah, good, they're no longer there. I already deleted them. So the second time it's going through trying to drop these columns, it's like, I don't see these columns. They're not found in the axis, in the column axis, right? So this is a case where if I want to rename my data frame, now that I've already run this once, I do need to come back in and re-import this data set quickly. And remember, I can just Shift-Enter to run these columns. Might take a minute because we're using the Python engine now instead of the C engine. It does have a cost. All right, so I want df1. So now df still has the original columns. df1 has it without, right? So I got 2 copies of my data frame saved to these 2 different variables. That way, from now on, if I needed to go back, maybe it wouldn't have to go back all the way to the very beginning. Could you have chosen to drop those columns from the beginning when importing the file? Yeah, if I knew at that point that that was already something I was going to need to do, I could have done use calls, and given it a list of the specific columns I wanted to retain, and it would have dropped them from the beginning. So there's actually quite a lot you can do with just the read CSV call to get you where you need to be, but typically you won't know exactly what columns you need before you start. You have to do a little bit of exploration to figure out which columns are the most useful to you, but yeah, that is possible. All right. Whew. We're finally to the point where we can start cleaning up some columns, right? We're going to clean up this interest rate column, and after we do that, we're going to take a short break. All right. So what I want to do with this interest rate column is I want to remove the % sign, and remember that this column had the data type of object. So I also want to coerce this to be numeric. I want this to be a float. So what I'm going to do to practice this, right, is I'm not going to go haul off and write some magic code. I'm going to start as simple as I can and leave myself a really simple kind of use case. And I'm trying to write code that'll work on that really simple use case, and then I'll kind of make it more complex as I go along. And I'll show you what I mean as I type this code out. And I think this is a good way you can approach writing your own code. And I'm going to leave each step of the code that I write here in the notebook so you can kind of see my thought process. But I want to remind you that we have int rate. So this will just give me the first 10 rows. Right? We've got percentages here. Data type is object. Right? Let's see. So what I'm going to do is make an int rate variable, and I'm just going to make a fake interest rate. Right, remember that these interest rates also had leading spaces. I think Pandas might have actually read them in without the leading spaces. Yeah, they still have leading spaces. So we do need to account for that in kind of our test case. So here's just a single interest rate. If I can clean up this single variable, then I can do it to the whole column, right? Because I know that the same problems this variable has is the problems that the whole column has, right? So let's take a look. I'm actually going to copy this in. We're going to work with exactly the same interest rate. All right. So the first thing I want to show you is that there are specific methods on Python variables that are specific to the type of data that's held. So the fact that this has a string variable means that we can use string functions or string methods. Right? So here's a list of all the different string methods we could use here. Augustine asks if there's a shortcut to adding cells. There's all kinds of shortcuts. If you come here to Tools, and then Command Palette, Control-Shift-P, add a code cell, add a comment. These are all the keyboard shortcuts of all kinds of things you can do in Google Colab. So take a look at that. You're only as good as your tools, right? So as you learn more keyboard shortcuts, you'll be able to work faster and faster and get more done. Encourage you to take a look at these. Anyway, so interest rate. The first string method I'm going to use is .strip. Does anybody know what the .strip function does? And if you're not sure, take a look at the program is link I just sent you. Good, yeah. So .strip will remove characters either at the beginning or the end of a string, right? So if I do .strip and I pass in a %sign, it will strip the %sign because the %sign is at the end of the string. If I call this, but I don't put anything in it, right? If I just leave these parentheses blank, the default behavior of .strip is to remove white space, right? So if I call this blank, then it removes the white space. All right? So I'm going to make a little comment here. Strip removes characters that exist at the beginning and end of a string if nothing is passed into the parentheses. .strip removes white space by default. All right. So one thing I can do here is something that's really important in programming. This is going to be an example of what's called chaining. Chaining means I can call multiple functions one right after the other. So I can say int rate .strip, and that will remove the white space, and then say .strip with the %sign, and then that will remove the % sign, right? So remove leading or trailing white space, remove leading or trailing % signs, and that will clean it up 100% of the way. All right. So you can see how I didn't haul off and write this line of code right at the beginning. First off, I kind of gave you that this was the function we needed. You might have needed to Google how to remove white space or how to remove %sign from a number or from a string, right? And then come across this, maybe this function, maybe others. There are other functions that we could use to do this. For example, the .replace that Robert has just shared would have worked as well. So I'm replacing instances of % with an empty string. And that would have worked. And I could also maybe do .replace, and I could replace spaces with no strings, or I could replace both, right? There's multiple ways to do this. I can also chain these .replaces. Or I could use a .strip and a .replace, right? There's multiple ways to do this. Is it PC if I say skin a cat? No, it's not, huh? There's usually more than one way to do things. All right. Okay, so at this point, we have one more thing to do. We've removed the % and the spaces, but this is still as a string. Like I can still see the quotation marks around here. So What I'm going to do next is I'm going to do what's called casting. Cast a string to a float. Cast means force something to have a different data type. All right. So what we're going to do here to cast this to be a float, first off, I'll just remind you that this is indeed, I can use the type function to check the type of a variable. This is indeed still a string as we start with it, right? So we're going to go from string to float. And I want to turn this into a float by just calling the float function, right? I can make anything a float, 4.58, right? And now that's, notice there's no quotation marks here. So here's an example of casting something to a float and then just being certain that it actually is a float. Right? So this is casting, right? Remember that vocab word in case you hear somebody else use it that way. All right, at this point, I think I'm ready to write a whole function. And I'm going to call this function int rate to float. You can call it whatever you want, really. But what this function is going to take in is it's going to take in an interest rate, or maybe an interest rate string, right? And what it's going to do is it's going to return that interest rate string stripped of white space and stripped of percent signs, and then all of it cast to a float. All right. So this is kind of a medium complex line of code here, but you notice I didn't write it right at the beginning. I didn't get there all at once. I kind of built my way up to it. Now let's see what happens if I call int rate to float and I give it my int rate from before, this value. What is it going to return to me? 14.47. And if I check the type of the thing that's being returned to me, I see that indeed it is a float. All right. So I know that this function works the way that I want it to for a single interest rate. So I know that if everything else in a specific column has that same problem, this function should be what I need to fix things. But you might be asking yourself, wait, but doesn't this function just work on a single value, on a single cell of a column? And that's exactly right. We are going to write our function here as if we were going to loop over the column, right, and apply this function to each cell individually and replace each cell one by one as we loop over the column, and then use that to create a new column. But we're not actually going to write that for loop. We're going to use a fancy pandas function called the apply function. All right. So if I say, I'm going to call the interest rate column here, and I say dot apply, and then I give it the function I've written above by just giving it its function name, int rate to float. The apply function will take the function that I've written. It's going to automatically loop over the interest rate column for me, and it will apply this function to each individual cell and return to us a column with the replaced values. All right. So you can see now it has the data type of float. We don't see the percent signs as the leading spaces anymore, which is awesome. We have just cleaned up the interest rate column, right? Now it's something numeric that we can work with. All right, so the apply function is aptly named. It's called the apply function because it will take a function that we've written and apply it to each individual cell in a column and then return to us the result. It will return to us the final example. Does it save over the original data frame variable? No, it doesn't. It does not imply in place by default. So if I say df1.head, notice my interest rate still has the percent signs. All right, so I need to explicitly save over this. And now I have cleaned up the interest rate column, saving back over the original column with the cleaner version. So yeah, it does not do in place by default. We have to tell it to save over the original column. Does apply do rows too or just columns? Well, that's a good question. I've only ever really used it for columns. I think it could work for rows as well. But you have to remember that the apply function would need to work the same way for every cell in a row, which is typically not the case with our data sets. All right. If it works for every cell in a row, then it's probably going to work for every cell in the whole data frame. And at that point, I could just call .apply on the whole data frame instead of on a specific column. So yes, I think you could make it work, but I think you'll rarely need to, if ever. All right. So that is, first off, we're accessing columns or making changes on whole columns here by saying df, then the column header, and then calling some values on it. I wrote a function that should work for any given cell of that column, but I didn't write this function all at once. I kind of built up to it, experimenting in my notebook. I gave myself a really simple use case that I knew if I could fix this use case, then I could do it to any cell in the column. And I eventually ended up with, maybe 2 cells of fairly slick code that are going to really handle this cleaning of this column for me. All right, so when you see really nice notebooks that have been well manicured and kind of cleaned up after the fact, just know that the person who wrote that notebook, the code didn't just come into them out of thin air. They had to do a lot of writing and rewriting and experimentation. Yeah, I can scroll up. Let's see. There you go. Is that what you need to see, Christopher? You'll probably take an iterative approach to the code you write. And it's sometimes maybe a little bit silly that at the end of the day, you've spent hours and hours and hours and you end up with 12 lines of really good Python code. But it's more about the lines that it took you to get there and to learn that that was even the problem you needed to deal with and how to deal with that problem. So don't really measure your success in lines of code. Measure your success in kind of objectives completed, right? And people who count lines of code, particularly data scientists who count lines of code, are a bit silly, in my opinion. Augustine says, be Pythonic. So I'll say that very quickly before we take a break. When we say something is Pythonic, we mean that there's one clear way of doing things. So the way that we fixed this interest rate was not necessarily Pythonic, because there was 2 ways to do it. We could use .replace or we could use .strip. But the Python programming language typically tries to make it so that there's one clear and obvious way of doing something. But when we're using pandas, for example, that's not always the case. Pandas is built on top of Python and doesn't always follow that mantra. Other libraries really don't follow that mantra, like some of our plotting libraries. But I think it's a good thing to strive for, is that simplicity in our code, right? Yeah, these are the real money makers here. Again, if you guys are trying to see my code, just go to the lecture notes link that I shared with you at the beginning of class, and you can refresh the page, and this should all be in there. All right, but we are going to take just a 5-minute break. And when we come back, I'll answer some Slido questions and we'll continue on. I'll leave this shared here for 5 minutes, but go ahead, take a 5-minute break, use the restroom, get a drink. See you back here in a few minutes. All right, come on back. We'll get going again. All right. Share my screen. So we're going to try and clean up one other column before we get working on things. Let me answer some slide questions and also a question Travis just asked. Travis says, should I be cleaning up my notebooks? I've been leaving them messy to show my work process because I figure it would make it easier to provide feedback, but is that preferred? I don't normally, only because it's a school thing, but if it's not necessary. So I don't think you need to like really clean up your notebooks unless like your notebook is so messy that your team lead's not gonna have any idea, excuse me, your team lead's not gonna have any idea like what you're doing, what you're trying to do. So maybe clean it up a little bit, but you don't need to go really overboard there. Now, there will be times where we work on projects that are intended to be external facing. They're going to go in your portfolio or something like that. In those cases, yes, clean up your notebook as much as possible. But if it's just kind of for practice, then I think it's maybe even better to get feedback that you can show your work. So kind of personal preference there, but yeah, I don't think you need to clean them up a whole time. A question, is there a good way to remember the path when we try to save a copy so that we stay organized? I think the easiest way is to just have the repository open, keep it open as a tab, and then be able to copy the name of the folder when you save back to GitHub. That's honestly the easiest way that I found to do it, is just refer to the folder name here on GitHub so that you make sure when you save it, it goes back to the right place. Also, another question we have here in Slido. Do most data frame methods take in place as a parameter? The answer is, if a data frame method modifies the column or the data frame itself, then yes. This follows a principle of, of functional programming, and the principle is that you shouldn't directly mutate or change or modify, right? Mutate is kind of a fancy word. Something that you are operating on, right? So if I were to call this apply function and it immediately changed the interest rate in my data frame, well, then I would only be able to run this once, right? Once it's changed, maybe then this wouldn't work the same the second time. So I'd have to go back and I'd have to reload my data and then maybe make a tweak to my function here and run it again. So the general principle is that you don't directly mutate an object, you make a copy of it, which is why many of the functions that make a modification to a column or data frame, they don't do in place by default. They will return to us the modified copy. Now we can choose, excuse me, man, I really got a frog in my throat today. We can choose if we want to save over to the original and still do that in place mutation, but it's even best practice to not do that, to make a copy every time you mutate something. Now, within reason, that can get a little bit out of hand as well. Another thing is that the in-place parameter, there's been talk of deprecating it or removing it from pandas, which is one reason why I typically don't use it. I just save over whatever I want to save over. So that's why you'll see me not use it a whole ton, but it's still valid. It should work for quite a while. All right. Sorry, man, my throat. Take a drink, see if that'll help. All right. We're going to work with the employment title column, emp title for short. So let's just take a look at the employment title column. You see we've got a whole bunch of different employment titles. So, because anyone can type anything in here that they want, let's maybe say emp title dot value counts. All right. Now we've got some of the most common employment titles and least common employment titles. Let's then maybe sort this. I think it's actually maybe already sorted. Let's see. What do I really want to do? Well, something I'll point out, I'll take this value counts off for a second. We had an NaN value here. So we know there's some people who have left this blank. Maybe that means they're unemployed. Maybe it means they just don't want to say what their employment title is. Maybe they work somewhere where it's really ambiguous. So I'm going to say drop NA equals false here. on this value counts. And that will then include NA values. Right, so you notice that I'll remind you what the shape of our data frame is. Of the 128,000 some odd loans that have been issued to different people, about 1/6 of those loans, we have no employment title for them. All right. Now, again, is this a matter of missing data or not applicable? And it's not as easy to say one way or the other here. probably some of both. But what's important to know is that we've got lots of missing values in this column, and this is really going to affect how we work with this column because, let me show you. Type, well, have I imported NumPy? I don't know if I have. Yeah, looks like I haven't. All right, so import NumPy, and let's look at the data type of an np.nan. Oops. So a nan value has a data type of float, which is weird. So the reason for this, if there is a reason, is that nan actually stands for not a number. NaN, not a number. And so this has a numeric data type, because if you do like a divide by zero error or something like that, you'll get a nan. There's different ways of generating nans, but it's in data science and in pandas, we use it as the general null value or missing value indicator, but it really means not a number, so it has the data type of float. And this is going to be really important because this column holds mixed data types, right? In general, it has let's just look at the first 10 values of employment title here. In general, it has strings, but these nan values are floats. So we have string values mixed with floats in this column. And so as we deal with it, we need to keep that in mind. We might need to do a little bit of type checking to make sure that the function that we write to clean up this column works the way we expect it to. All right. So if I want to get just the top 20 job titles here, what if I just do this? Give me the first 20 items in this list. There we go. There's the top 20 job titles, right? So as you can see here, we've got a few different things going on. We've got lowercase issues. We've got nan values. We've got, initials, RN, registered nurse. Now, we're not going to be able to clean up everything in this column. What I really want to do is I want to decrease the number of unique job titles, right? So I'm going to just make I want to decrease the number of unique job titles. Because I think there's, for example, manager here and uppercase manager. At a minimum, those two should be combined. Those are the same job title. They just have different casing, so they've been registered differently. So there's some instances like that where I want to clean things up. So first off, let me see how many unique job titles there are. And one way I can do this is do dot value counts. Remember, dot value counts returns to me a different row for each unique job title. So if then I just look at the length of that value counts, it'll tell me the number of unique job titles. So I'll make a note here, just making that clear that's what I'm doing. Get number of unique job titles for cleaning. It's good to leave a little comment if you have some code that you don't think its purpose is entirely clear. You'll see me do that sometimes. All right. So yeah, we'll just do that. Okay. So at this point, I want to again. Oh, how often is emp title null? We haven't answered this yet. Well, we kind of did here. 20,947. There's maybe some other ways you could answer this as well. I'll just give you one quick example. So we have done examples where we'd say df.isNull.sum. Oh. don't know why I didn't choke on this 0, right? And that'll give us the number of null values of every column in the data frame. Well, if I don't call this on the data frame, but I call this on a specific column, then it will just tell me for that column, right? So 20,947, 20,947, all right? And at this point, I am ready to clean this and handle some missing values. But you'll notice that I have more than a few cases of what I want to deal with here. So I'm going to make, just like I did before, I'm going to make some specific examples. Before I just used a single interest rate with the leading space and the percent sign. Here I'm going to give us a few different examples. So something that's lowercase, something that's uppercase, something that maybe has a leading space, and then nan value. All right, so these are the 4 different corner cases that I want to kind of clean up with my function here. And so again, I'm not going to start doing this on the whole function. I'm just going to make myself a little example that's easy for me to reason about, easy for me to understand, to make sure I know what's going on here. And I'll make a function. We'll do that as a start here. And I'm going to call that function clean title. And remember, it's going to look at each individual cell. So it's going to look at each individual title one by one. So that's why I'll call my parameter here title. Hopefully my code's a little bit self-documenting. At least that would be the goal. So what I want to do, I want to strip white space. And then I also want to give things a specific casing. Now there's a couple of different ways to give spacing. So I'll say title.strip to handle the white space. And then I'll say .title, and this will give title casing. Let me return this. And then I'll say something a little bit tricky. All right, this is gonna get a little bit tricky. This is what's called a list comprehension. This is something that you don't need to know, at least don't need to have memorized today. It's not a specific objective today, but it's a way of combining a for loop and a function call when you're looping over a list. All right. All right. So loop over examples, and then for each item in examples, call clean title on each of those individual items. So this is doing something very similar to the apply function, but instead of being called on the column of a data frame, I'm calling it on the items of a list. All right. So, and name examples is not defined. Oh, for item in, did I not run this cell? Name examples. Do we need to fix the error in examples? Where's the error? Oh, MP, you're right. Thank you. Oh, I just totally spaced that there was an error message there. All right. Float object has no attribute strip. Float object has no attribute strip. What do you think is going on here? Okay, I can't call .strip on the nan value, right? So it's looping over the items here, and when it gets to np.nan, then it says, hey, floats don't have a strip function. I can't do this. So if I take np.nan out, then this will work, right? But if I put it back in, then I'll get the error, right? So when we're working with columns, say this one more time, we have to be conscious of the data types of the items that are in the columns. Now, df.dtypes shows us the most common data type in a column, but remember, nans have a data type of float, which is going to also cause you some problems on the assignment. So you need to remember that nans have a data type of float. So what I'm going to do is we're going to have to do a little bit of type checking. All right, so I'm going to say if is instance. Now I wouldn't have expected you to pull the if is instance function kind of out of nowhere, but you would Google these things and you'd figure out, okay, this is the way to check if something is a string or not, right? So if this title is a string, then if instance will return true. right? And if it returns true, then I'll get inside of this if statement, at which point I will want to strip it and give it title casing. If it's not a string, then I will want to maybe let's remove nans from this column, right? Maybe I don't want those float values, so maybe I'll return something like unknown, right? And this is going to make it so that everything is going to be a string after I run it here, and the nan gets replaced with unknown. So this is type checking, right? I'm doing something based on the type of item that comes into the function. And it looks like this has cleaned up things in the ways that I want, right? So, excuse me. Now I'm ready to apply this to my column and then see what happens. So say df imp title dot apply, and remember I just give it the function that I've written, and it's going to automatically loop over the column and replace the values with whatever gets returned from this function. All right. So we can even see at the very beginning, this bus driver used to be all lowercase. Now it's got title casing. Remember, title casing just means we're going to capitalize the first letter and we're going to lowercase all of the other letters. So I'm going to save this over the original employment title. All right, that's been saved over, and now I can take a look at maybe my top 20 again. So my top 20 employment titles. Okay, notice that, oh, I still called it on DF1, my bad. There we go. We used to have manager and manager. Those have now been combined here. And notice we didn't handle this RN, this registered nurse. It's just kind of messed up the casing here. So we've made our code, we've made our data better in some ways and worse in other ways. Let's see how much better we've made it by looking at the number of unique job titles here. So we've gone from 43,000, maybe 44,000 if we round up, down to 35,000. So we've removed or cleaned up 9,000 unique job titles and combined them together. This is going to be better for my data set if I have this better indicator of job titles, right? It's a little bit cleaner. It's not perfect, but we're just practicing working with these columns, which I think this has given us a good, another good iteration of how to clean a column, but also dealing with those pesky nan values that can sometimes be tricky. Yeah, Travis says, the function and the variable name should tell what's happening or what you're working with. The code should say how it works, in the comments why. Yeah, I think it's a great tip. Keanu asks, why did it display it backwards that time? Value title rather than title value. Do you mean here in the value counts? Where specifically are you referring to? When you initially applied it? Right here. Oh, dot head versus value counts? Or do you mean here in the list comprehension? I'm still a little bit confused. And you can even just unmute yourself if it's easier that way. Where did we make everything begin with an uppercase letter? I think I missed that. I still have manager and manager. Yeah, so we added .title here. So this gave our string title casing. So we stripped white space and then we made it so that the first letter was capitalized of every word, and all the other letters are lowercase, specifically title casing. So if you got, I just add this on to your clean title function. Alrighty, I'm gonna keep on going because we don't have a ton of time left. I want to show you one other really important skill from today. All right, and this skill is called data frame filtering. All right, let me even just make a new text cell. I'm gonna say data frame filtering. This is very important. Okay, data frame filtering, what it really means is that we're going to split our data frame into at least two different data frames based on some specific conditions. So we're going to subset our data frame based on specific conditions. And this is a really useful technique with pandas. All right, but before we do this, I want to make a new column on my data set. And then we're going to filter based on that new column. So this is something we haven't done yet. We've just saved over the original columns as we've cleaned them up. We haven't made any new features yet. We haven't done any quote unquote feature engineering. We've just done some cleaning. All right. So what I'm going to do here is I'm going to make a new column on my data frame, and I'm going to call it employment title manager. All right. What I want to do is I want this to be true if the employment title of that row contains the word manager, but false if it doesn't contain the word manager. So there's a really useful function here where I can say emp title. This is particularly a string method, so I have to also say that this is a string here. Dot contains manager. And I'm going to say this over df1. Excuse me. All right. Well, d1f, df1. All right. Now, new columns when they get made on my data frame are all the way over here at the right. Right. Emp title manager, false, true, false, false, true. We'll see if the words manager are in rows 1 and 4 here. Manager, manager. Right? So this is my brand new column. This is a column that wasn't in the data set originally. Now, the question when you're making a new column is say, does this column say something that the original columns of my data set didn't say maybe quite as clearly? And I think it does. Like this has pulled something very specific out of our employment titles and now can be indicated with, this just this binary variable. Is manager in the title or is not? Is this person a manager or not? Now, is this a perfect indicator of whether or not a person is a manager or not? No. But it's a start, right? And sometimes we just want to do the best that we can with our data set, and we'll have to live with a little bit of noise, a little bit of imperfection. So now what I want to do is I want to filter my data frame based on this new column that I've made. All right, I want to make a column. I want to make a data frame that has all of my managers, and I want to make a data frame that has everybody else. All right, and now I can do it very easily because it's really easy to write conditions based on this column. All right, so what I'm going to do, this should actually maybe be down here. Data frame filtering, very important. Triple exclamation point. All right, I am going to write a condition. Just like if this was an if statement, right? But I want that condition to work on the whole series. So I'm going to say if emp title manager is true, right? Double equals, because I'm doing comparison here. What this will do is it will, let's see, df1. It will evaluate to false everywhere where this condition is false, and true everywhere else true. So what you'll notice is this is exactly the same as my emp title manager, right? But I'm going to leave it this way just to be a little bit explicit about what my condition is that I'm filtering on, right? So the way to filter is act like you're going to go and access a specific column in a data frame, right? You put the square brackets on. But instead of putting a column header in here, like I might do, you know, some column header, I'm going to put my condition inside of here. What this is going to do is it's going to retain the rows where this condition is true, and it's going to omit the rows where this condition is false. So I'll put that here. Retain rows where the condition is true, omit rows where the condition is false. And I'm going to say, I'm going to call this my manager's data frame. And then managers head. Let's take a look at them. Manager, 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 manager. All right. Likewise, I can do the opposite. I can make a non-manager's data frame, right? And I could say this condition, but if it's false. All right, so I could make a new condition and save it to a variable, then just pass the variable in, or I can just, you know, put the condition in directly inside of the square brackets. Either way works. Whatever you think is can be more clearly understood. Oh, dot head. All right, now none of these people have the word manager in their title. Show me the data frame where df column equals the value on every row. I mean right here. So what's kind of funky about this case? Could you use df not condition? Yes, I think I could. Let me try it. So this is the negation operator. Not certain if this will work. Yeah, it does work. So this negates my condition above, right? So do the opposite. It will retain things where the conditions, well, it's just going to flip trues to falses and falses to trues and give me the opposite instance. How come you're calling df1 twice in your non-managers? I'm just trying to make sure that I filter based on using the data frame that I already cleaned. Is really the only reason why I've switched to using df1 everywhere. I haven't been super consistent about that, but yeah, I'm trying to use df1 everywhere to just make sure that I am cleaning things up the way that I want. So tilde is that a pandas thing? I think the tilde might be a pandas thing. I can't remember if it's a Python thing or a pandas thing. Sometimes it gets a little blurry for me, which is kind of silly. But I work with so much with pandas that sometimes those lines blur a little bit. I spelled it wrong. Yeah. The unary operator. It means where we're negating operands. I don't know if this is going to be a great resource actually. Yeah, I don't like this resource. Anyway, I'll find you something really useful if you want to learn more about this negation operator. But it's toggling trues to falses and falses to trues, which is why let me just even give you the other ways that I had this before. So I could say something like this. That should work. I could also say this. That should work. All right. But I'm gonna comment these two out, and we're just gonna use the last one because I think it's the most elegant. We're just doing the opposite of our earlier condition to get the opposite subset, right? But this is maybe a little more explicit. And I think this actually needs to be false. All right. So different examples of data frame filtering. What's the moral of the story with data frame filtering? Whatever condition I pass here into the square brackets, if it evaluates to true, that row gets retained. If it evaluates to false, that row gets dropped. And that is data frame filtering. Now, let me show you somewhat the usefulness of this. Is now I can ask questions or do exploratory data analysis based on these two subsets, based on these two samples, so to speak. All right. So if I wanted to do something like, I want to look at some summary statistics of just my managers. Right, I can see that managers have an interest rate that's average is 12.76. So I could also maybe even just do managers int rate dot mean, right? 12.76. And then I could ask, okay, are managers getting better rates than everybody else? I don't know. Non-managers dot describe. Right, and I can ask questions about these two different groups because I've split my data frame based on who's in the group and who's not. Let's see, non-managers. Okay, so it looks like non-managers are generally getting a higher interest rate than managers. Is that a causal thing? Are we just getting lucky? Do people trust managers more and they give them better interest rates? I don't know. We can't really say anything definitive about that, but this gives us the setup we need to even start thinking about asking that question, right? I could maybe likewise create some plots. I'm going to import Seaborn here. I haven't shown you how to use these plots quite yet, so I'm just going to copy and paste here for a minute. Oh, I called this non-managers. Right. And I didn't rewrite this. All right, so here's a kernel density plot of, yeah, I used to call it plebeians in past lectures. I call it non-managers today. I figure it was more kosher. But yeah, are these distributions different? They're similar in some ways, different in other ways, right? Is that significant? I don't know, but we couldn't have even made this plot until we had the data frames done in that way. I'll also do another fun kind of Seaborn thing, which will combine both histograms and density plots, which is kind of fun. See, now we have both a density plot and a histogram. All right. So Amaya says, so this is how people on the presentation were able to explain their data sets. Yes, so we're building up to a lot of the data storytelling that you saw in the Unit 1 projects, right? If we have a specific question we need to ask, sometimes we want to split the data frame into different subsets so we can ask questions about, kind of compare and contrast different groups, different demographics, etc. David asks, is Seaborn built on top of Matplotlib? Yes, it is. So essentially, these Seaborn functions are calling underlying Matplotlib code. So on Thursday of this week, we are going to work with Matplotlib, and then we'll also get into a little bit of Seaborn a little bit later. Yeah, Travis says, to reasonably say that something is true, we need to rule out as many possibilities as possible, which means generating possibilities. And with every possibility comes a new method of testing against it, which requires data. The more accurate you want your truths to be, the more data and analysis are necessary. Computers are very bad at this, which is why we are needed. Yes, so next week, we will look at hypothesis testing and t-tests. And we'll be able to test if this manager's mean is truly different than the non-manager's mean. Assuming that we had a truly random sample, which we don't in this case. But we could sample from this randomly and then do some hypothesis testing. Another way of, if you want to prove causality, is is representing the counterfactual. Means, okay, so this is the current state of the world, but what would the state of the world look like if the managers didn't have manager in their job title and the non-managers did? I don't know. Like, can you also answer the opposite question to show that there's truly a difference, or if this is just something that happens naturally? Anyway, we'll get a lot more into discussions about that as time goes on. I don't want to get too far into this tangent because we still have one more topic to talk about today, and that's how to work with date times with pandas. But I hope to show you that working with date times here is really easy, scarily easy. If you've worked with date times in other languages, other analysis tools, it can be a real pain in the butt. But with pandas, it's really nice. All right. So one thing I'll point out first is, well, if I say df.columns, this will tell me all the different column headers. But notice it gets truncated. It's wrapped in this index. If I want this to be a really nice list, I can cast this to a list, and now I have all of my column titles. Maybe easier to see, maybe not. What I want to point out is that a lot of dates here in this data set have underscore D at the end, right? So underscore D there. Let's see, underscore D, last payment date, next payment date, last credit pull date, right? So there's a lot of things that are supposed to be date time objects here, but if we look at our actual columns again, we'll see that we don't really see any date times, right? Let's actually find one. The one we're actually going to work with is issue date, and you'll see that it's an object right now. It's being read in as a string, so it's not really being thought of by pandas as a date, right? So the first thing we're going to do, we're going to take that issue date, and we're going to cast it to be to have date time format, right? So we're going to say issue date, and I'm going to say pd.toDateTime, and the thing I want to cast to a date time is again this issue date, and I'm going to say infer date time format equals true. And let me show you why I'm saying infer date time format is true here briefly. Oops, I was supposed to say df1. That's okay. I'm getting all my dfs mixed up. I'll go back through after lecture and clean up my instances of df1 and df2 so it's a little bit more consistent. I've made a couple of flubs. All right, so here's the string values. It's month-year. And even though these string values are strings, this is still a common date format, right? And it's a common date format that pandas can see, okay, this is obviously month-year. I know how to infer that date time format, and I know how to make that work, right? It's been built into pandas here. So if I say df1.dtypes, right? Coerce this to be a date time object. Then we'll look at the date types, excuse me, the data types. We can see that issue date is now a date time 64. All right. Now the coolest thing about date types is not doing this this type casting or this coercion. The coolest thing is that now that we have this as a date time object, pandas makes it really easy to work with dates. All right. I want to add a couple of things here just for our notes before I move on to demonstrating that. I want to show that, come on, we can easily get all of the dates that end with D using another list comprehension. So pardon my copying and pasting here, just trying not to go too far over time with lecture. All right. So here's all the different things that have the column name ends with underscore D. So kind of fun to play with list comprehensions. You'll get better and better at them over time. Again, this is not the focus of today's lecture, again, which is part of why I just copied and pasted that in there. Mike asks, so why don't we have to use the apply? Because this is a built-in function? That's exactly right. So this built-in function is going to do this for us. If we used apply, we would have to write our own function that would look at each date individually and cast it to a date time. and this is just going to do it on the whole column for us. So a lot of times with pandas, there's this built-in stuff that, yeah, it would be a pretty ugly function. That's true. This is a kind of a slick one-liner, and we kind of got lucky the fact that these date times are so organized in this data set, which allowed us to infer the date time format. If we couldn't do that, this would be a little bit more challenging. But typically, if the date has been saved, it's been given a fairly conventional string format. Yeah, most of the time you'll just be able to infer it. If you can infer it, things get hairy fast with dates, but usually that's the case. Okay. What if it said October/2020? There's a way that you can indicate what the separator is. So there's a bunch of different types of date time format. There's like a billion jillion of them, but you could specify the date time format. You might say something like month, year, right? And this is the separator. This is not exactly right, but it would look something like this. Yeah. So you can get specific about the date time format, but for today, again, we're just going to let it infer. Oh, this should just be true. All right. So the default argument for inferred date time format is false to be regularly specified as true as data scientists. Typically, it really depends on how your data looks. If your data looks like it's in a common date time format, you could use infer equals true. If it's something wonky, you're going to have this be false and specify something else more specific. Could you go over again what this line of code does really quick? Yes. So this is taking my issue date column. You'll see the items here look like this. And it's taking them from a string, which is literally the characters OCT-2018, and it's turning it into a date. So it will act as a date in pandas, and we'll be able to do some cool things based on this point in time. So pandas has useful things built in that account for leap years, that accounts for all the odd things that have gone on with our different calendars, and we'll be able to very accurately calculate amounts of time between two events without really us needing to do very much at all. So this date time format is very convenient if you want to do some cool things with dates. So let me show this briefly. All right, so let me first off show you what the new issue dates look like. This is kind of their new format, and if I look at one of them specifically, let me put this down. You'll see that it has year, month, day, hour, minute, second. All right. Yes, if you've worked with C++ or the libraries working with dates here, you'll be blown away by what I'm about to do. All right. Hopefully that makes sense here in a minute. We could also, if these date time values actually hold more than just hour, minute, second. You can get down to crazy millisecond values. So this is an extremely specific date time. But because all we had was the month and the year, everything else after that is just zeros, right? So, and it's assuming that this was the first day of December because it wasn't specified, right? So all of this is just kind of put away by default. All right. So here's what I want to show you. This is the cool part. If I call this issue date column and say .dt, then .year, then I'll get just the year values. If I say .dt .month, then I'll just get just the month values. And this is the same if I say .hour, .second. I'm not sure what it is for millisecond. I haven't ever had to use that before. I typically stick with year, month, day. All right. But now I can create new columns in my data frame based on this. By the way, when you create new columns of your data frame, you have to always use these square brackets. You can't use the dot syntax for creating new columns. You have to always use square brackets. So let's say, let's call this issue year. And I'm going to make a new one, another one for issue month. All right, so I'm taking this date and I'm splitting it into unique columns. And I should do this with all with DF1. Oh man. All right. Remember, as I create new columns, they show up all the way on the right, and I should have an issue year and issue month. Now these are, after I pull the month and the year off, these have integer data types now. They've lost that date time ability. They're just the raw integers now, but now I can do cool things with just the year and the month as integers. But here's the absolute coolest thing. You ready for this? If you've ever had to write your own libraries to work with dates, your own code to work with dates and to handle leap years and all this garbage, what I'm about to do will blow your mind. If not, you might just be like, oh, that's nice. But if you've had to deal with this before, you will really, really appreciate it. All right, I'm going to look at a different column here. I'm going to look at earliest credit line, right? So this is when the person's credit history began. And notice for people of different ages, it kind of started at different times. And I want to make this have a date time format. I'm again, sorry, I apologize for this copy and pasting here, just for time's sake. All right, so now it has date time format. Now here's what I want to do. I want to make a new column. And I'm going to give this kind of a verbose name, but it's going to say days from earliest credit to issue. So I want to know the number of days from when their credit history started till now. Oh, DF1, thank you. Again, I'll have to go back through and fix all that. So I don't usually rename my data frames. I'm not in that habit, which is why I always forget. All right. All right. So days from earliest credit issue. This is the new column I'm going to make. And what I want this to be is I want this to be the amount of time between the issue date and earliest credit line. And I want to get just the days from that, right? So with only the subtraction operator here, Pandas is going to see that both things on either side of this, thank you, on either side of this are dates, and it's going to automatically calculate the amount of time between these two dates for every cell of both of these columns. And then I'm going to say, well, how long was that length of time in days? And I'm going to save the number of days between these two dates to a new column on my data frame. The fact that I can calculate the length of time between two things with just a subtraction operator is kind of bonkers. All right, so here's days from earliest credit to issue. Yeah, the parentheses allows me to take this and it's saying, okay, calculate the length of time first and then get me the days, right? So the parentheses, I couldn't call this on this because all this is going to do is going to grab the dates here on the earliest credit line. And I don't want the days on the earliest credit line. I want the days on the distance or the amount of time between those two dates. Yeah, so that's what the parentheses are for. All right, kind of crazy. Now I have a new column that is really informative, really valuable. If a length of person's credit history says anything about their credit worthiness, then this column will be a really good indicator of whether or not this will be a person that's worthy of loaning to, right? If they've had a longer credit history, they might be more creditworthy, right? I could check and see if that was correlated with anything I want to, but this could be a new feature based on working with dates that is really valuable and could really inform some of my predictions and any actions I take based on this data set, right? But it's all due to kind of this slick functionality with Pandas of working with date times. DT derives from Pandas or from Python. Neither, I think. I think it kind of predates both of them, some of this DT syntax. Other languages I've used have used it as well. It's common in like Stata and other things. Anyway, I think it comes as like kind of a predecessor to, I don't think it's in Python itself, which is why we have to use pandas to get this functionality. But yeah, it's in pandas. It's not in Python, but I don't think it comes from either pandas or Python. I think it comes from, it's a convention that was established earlier than either of those two languages. You will see this DT format when you're trying to format a date in a specific way or get a specific part of a date in some other date time management libraries or languages, libraries for even other languages like JavaScript or Stata or MATLAB or R. This is a somewhat consistent convention. All right, so that's kind of all I really wanted to show you guys today. I realized we went through the date time stuff really fast, but it's fairly straightforward. You take your string, you coerce it to be a date time, then use dt.days.months.years in order to grab the days, months, or years off of it. And you can also tell the amount of time between two dates easily with just a subtraction symbol, which is something that's very cool. The last thing I want to say is take a look at this. With this new column, we can analyze, we can ask things we couldn't before, right? So here is the earliest days from earliest credit to issue column, and the max number of days is 25,171. If we just divide that by 365, this is a person that's had a credit history open for almost 69 years, right? I don't know when their credit history started. Either this is an elderly person, or for some way their parents opened a bank account in their name when they were an infant or something like that. Or this is a victim of identity theft or something like that, who's already passed away and people went and took their personal information out of their gravestone. Basically, I think this is pretty cool. This is the longest credit history in the data set, and it's substantial. And this is something that we wouldn't have been able to answer nearly as easily without this person's information. So no, this the data set and the Lending Club has not been around 69 years, but this person's credit history has. I think Lending Club's only been around for maybe less than a decade. But anyway, let me go to Slido very quickly, see if I've missed any questions. How does the negation differ from exclamation point equal sign? That is a very good question. So, and this is something that I maybe should have spoken more to during the lecture. I'll make a small notebook up for you guys about this topic, because the exclamation point equal sign does negation of if statement conditions, but it negates a single variable. The tilde negates all variables in a list, right? So one operates on a single variable and the other one operates on a whole list. And if you have written if statements and you use or and you physically write out or, or you write out and, those keywords to compare sets of conditions, when you're doing that based on lists, you don't use the spelt out or or and. You'll use the ampersand for and when you're comparing conditions based on lists, and you'll use a single pipe for or. And I realize that probably doesn't make a lot of sense, me just mentioning that. So I will make a little notebook. I'll put that together during lunch that kind of demonstrates those two things, because that might be a little bit confusing. So on your assignment today, you'll be given 3 or 4 different tasks to go in and clean up some more of these columns, make some new data frame columns. One question asks you to cast something to an integer. Correct, like Travis says, single ampersand and single pipe in Python. Yeah. Sorry, the first question on your assignment asks you to cast something to an integer. But as you do that, you might notice, if you look at actual values, that it stays as a float. All right. That will happen if you have nan values in a column, because nan has a float data type. So if you try and cast something to an integer, but there's nans in the column, it will not go all the way to an integer. So if you really, really, really want it to be an integer, you have to deal with those nan values some way before you start, right? So don't let that confuse you on the first question. There's opportunities to write apply functions. There's opportunities to use data frame filtering. There's multiple ways to attack some of the questions on the assignment. So maybe collaborate with your fellow classmates. Don't be afraid to work together. That's not off limits. Just make sure if you're working with somebody else, don't like do their assignment for them. Don't rob them of learning opportunities. Kind of leave that to you guys to be wise about. Anyway, that's all I've got. I don't want to keep you any longer into lunch. Again, it's because I went 13 minutes over. Just take an extra 13 minutes to your lunch. Please take a full hour lunch break. Give your brain a rest. You guys have been awesome. I hope you feel your pandas chops getting better and better. Will there be a copy of lecture notes we can compare our notes to? Yes. So the link I shared at the beginning of class should have all these lecture notes in it. Just refresh the page if you're not seeing everything that's in there. All right, you guys are awesome. I'll be available in the afternoon after lunch for questions. Good luck on your assignment, and thanks for all of your participation and attentiveness. Really appreciate it. Thanks, guys.